Welcome in, everyone. My name is John. I'm a software engineer. I'm the lead maintainer of Latterly.io, which is an education platform. It'll help you land your first or next programming role. I made a meme TikTok earlier today, got a little bit of traction about I just Googled hard Leetcode problems. And then I thought, hey, let's actually try and do it. So I have never actually tried to solve this hard Leetcode problem. I'm also out of practice, so I think what I'll try to do is outline the algorithmic solution without the low-level code. And I'll probably cheat with ChatGPT and see if I'm on the right path, but definitely time box it to 15-20 minutes and look into the solution, which is my typical practice when I'm doing a problem like this. Then we'll also probably go do the Leetcode kata. So this is the way that I recommend people learn to code and get into a flow state and a regular practice of familiarity with various patterns. So it's much more concise than the Blind 75, Leetcode 150, and so on. And so, yeah. I will take a crack at this, and then after embarrassing myself there, maybe I'll recover by doing 2-sum and 3-sum. I'm going to quickly double check on my other screen whether Twitter is working. I think it's not. Oh, I guess it is. How strange. Okay, cool. Well, I may not be able to see your messages if you're on Twitter. Something strange is going on with my software, but it looks like the stream is propagating, so that's good. To everyone else, welcome in. Micah, got some folks on TikTok. So let's get started. So Leetcode. Like the actual website for Leetcode. Binary tree maximum path sum. Okay, so here's the problem number 124. And how would I go about solving this? So it's a tree. I'm given a root node. The left and the right are optional. The root node itself is optional. So I can handle the edge case. With a null root. Okay. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has a connecting edge. A node can only appear in the sequence at most once, so there will be, does that mean no loops then? That might mean no loops. We'll look through the examples, which would be nice. The path does not need to pass through the root. The path sum of a path is the sum of the node's values in the path. I think the ordinary path sum, yeah, so path sum is in the kata, but I just haven't done it for a while. So this is an extension of the ordinary path sum problem, which isn't too bad, if I can remember how to do it. Looks like we have integer IDs for each node. But I believe we can repeat the integer. I think you could have 2020, and it would just be a distinct node by ID. Okay, so the optimal path is 213, 213. And here, what would it be? 1527, right? Yeah, 1527. So what's the trick? The trick is I need to inspect every node. Okay? inspect every node. And then for a given node, I will want to, sum the left and the right. And the possible paths are left to self to right, or left to self, or self to right. So for each node, check 3 paths, left, self, right. So we'll check the 3 of these. And then what do? I think I need to go out to the leaves and sort of work up. Because I think it would be better to have null than like -1, right? Yeah, maximum path of any non-empty path. Oh, no. I mean, you could have a maximum which is a negative then, in that case. So what do we do if I'll just say if not root, return 0, I guess. We'll see if that errors on me, but I think that seems reasonable. Okay, so how am I going to traverse down the tree and then remember all of the locations? It seems to be like some sort of recursive or DFS algorithm. So let's say I recurse all the way down to, or like bottom up or top down. Do I want to do this bottom up or top down? Seems like bottom up is the way to go. So I'll have some sort of recursive algorithm which will get the best among children. Yeah. Probably I can just call this method itself. I'll separate it out because it's easier for me to think about, but I don't think that's necessary. I think the max path sum could call itself. Could call itself. So if there is not a root, return 0. Otherwise, we'll check left, check right, and then return max among options. Is it that simple? All right, this is going to be my approach, and yeah, I feel like my approach is overly simplistic, so I think I'm going to miss something, but let's go for it. So the idea here, the among options would be these options, these 3 options. Does that make sense? So I'll just call them LSR, LS, and SR. Equals left plus, self is going to be reserved. So I'll call this cur, or self.val. That makes sense. Plus right. And then we have the left plus root.val. And then we have the root.val plus right. And then I can just return the max among them, is what I'm thinking. I mean, maybe there's some problem with that. What would the problem with that be? Oh, there's one more. It might just be could I choose to ignore both children? The maximum path of any non-empty path. I think so, if I'm reading this right. So I should include that too. And then I'll say to do, maybe that's is illegal. I think I can do it though. So I could ignore both children if they're both negative. That's what I'm thinking anyway. All right, so the max, so what is LSR? So left. So check left. Left is self.maxPathSum of root.left, right? And then right is the self.maxPathSum of root.right. And then we'll go left, self, right, left to self, self to right, or self. We'll just get the max among those and return it up. And so let's walk through our test case here. So given that I'm at 1, if not root, we pass, right? So left will have a max of 2, and then right will have a max of 3. And it's a little more complicated than that because left will navigate into, and then left's children will be 0 and 0. And so it will choose the max between 0 to 0, 0 to 2, 0, or 2. So they're all going to be equal values, but the max ends up being 2 regardless. And so that we do end up with 2, 1, 3. And we want the sum, right? I don't need to preserve the network or anything. Yeah, so I get the output of 6 in that case. And then what about in this case? In this case, I start at the -10. And then left will be 9. And then the right, it will find the 1527, so 42. And then this will say, so what's bigger? Okay, and this is interesting because I could just use this right-hand path and ignore the self. Yeah, okay. So left, right. And then now it would pick the right and get that value. Let's see. Oh, am I not like signed in? I copied the solution on my clipboard. No worries. Grind 169. No, I just sorted all problems by difficulty. Oh, great. This is the wrong password. All right, let's see if I can figure this out. It's still here. Okay, cool. Good job, Leetcode. It might be on the grind 169. I don't know. I keep up with the kata, which is just 12 problems. Much easier to remember. Can't remember all that other stuff. So I'm going to my other tab and checking the password manager. It says success, but it's okay. That's the Cloudflare bot detection success, right? I think I need to like reset my password. Okay. Sure. Nice. For the win. Is there no don't enable it? There's no option to not enable it? Dude, there's no way. Okay, good. If I got the solution with that, this is not a hard problem. Okay, so I'm missing something, right? So what am I missing? If the root is -3, I output 0. Did I though? How did that happen? I would also expect -3. So if the root is -3, if not root, we should bypass that. -3 is not falsy in Python, is it? What? So we're going to check left. Oh, I've got it. It's checking left and saying that left is 0. That's the trick. It's checking left and saying that, oh, okay, interesting. So it's checking left and saying that left is 0, and then it's saying that, was the econ PhD worth it? Maybe. I mean, my year-to-date stock return is over 50%, so that slaps. But yeah, we'll see. I would say if I died tomorrow, it would not have been worth it. Like the ROI has not accumulated yet. But, you know, hopefully I live a long, healthy life. And so I believe I can definitely make it worth my own while over the course of the next 50 years. The research would say that in general, it's a good investment. Not all PhDs, but econ in particular. And then I think I beat the average by moving into tech. So I think that would be the more interesting question, Toto Buns. Rather than was it worth it, is it optimal, right? I think those are two different questions. So I think you can get a significant ROI of 8% plus, but I also don't. I also think that you can probably do better. You can probably do better. So that these days, even if you wanted to be contributing to true science, I think tech and data science are probably better ways. The economic mindset is super valuable. The material is super valuable. But contributing to economic research through the academy is not ergonomic. It's full of frictions that shouldn't need to be there. We just hit the 20-minute mark. I'll go like 2 more minutes in my time box here. Okay, yeah, so I mean the calculus is straightforward. It's saying that 0 is greater than -3, so it's returning 0. But that is illegal. That is illegal. I need to distinguish. Right, I mean, maybe I can just do this. Maybe I can just do this. Is it going to get mad at the max on none? Yeah, it's mad at the max on none. Okay. How do I get mentored by you? You can, you can go to latterly.io and join the Discord and message me, or you can shoot me a DM after the stream. Yeah, any of my social media here, just shoot me a message. Okay, so I have another idea. This feels cringier, but I could do a candidates array. So awesome, thank you so much. Very, very welcome. So here's a candidates array, and it'll start as empty, but I can say if root.left. Really, I want to comment this all below because it won't apply anymore. If I do this pattern, then I can return max candidates. So if root.left, then we can candidates.append. Right, and then we just repeat this for all the candidates. So there's left, and then there is right. So this would be left and right. That's fine. And then right by itself. Let's see. There's going to be a smarter way to do this, won't there? The smarter way to do this will be to check the root.val. So root.left, there's just so many if conditions. Okay. Yeah, there's going to be a cleaner way to do this. So here we'll take the max of the root.left plus good. I can just call this left. Left equals that. If root.right do I really need to do all the if conditions? Ugh, it feels so ugly. Okay. So if the root left and the root right both exist, we get all three of these possibilities, yeah? If there's a left, we have these two possibilities. If we get this far, we'll need to be able to append the root.val. So these are candidates for the best. So here's the root value. Then we say left, and then left plus root. And then if left and right both exist, we get the right plus root, right, left, root. Now, what if the left exists and the right does not exist? Well, I've already handled that, so I don't need that after all. But what if the right exists What if the right exists and the left does not exist? Then I'll have the right over here. I just get these two options. And then I return the max among them. What does this do? Okay, so that's accepted there. Previously, I think we got like 40 something of the submissions. So we got 46 out of 96 previously. Let's see what this new approach does. All right, now we're at 52. Okay, so we didn't quite get there. We'll look up the solution here momentarily. Pay attention and listen. Welcome in. Welcome in. Let's see why this answer was wrong, and then I'll go look up the final solution. Okay, so what I output is a 4. Why did I output the 4? Probably because I imagine that I can pick the 1 and the 3, yeah? And they want to say that the best answer is 3. And why would that be? Why should I not pick the 1 and the 3? I actually still don't understand that. Okay, all right, let's go look at some solutions. Subscribe to unlock, cool. Recursion stack thinking process diagram. That sounds awful. All right, let's check it out. For a single node, the answer is the value of that node. Dig it. These are simple cases. If both the numbers in both the nodes are positive, you just need to add them up. Cool. Okay, I feel like they haven't made any novel observations so far, right? We're taking care of everything so far. Right, so we're getting the maximum up the tree. Yeah, cool. I feel like somehow there's an implied tree structure here where the 1 cannot be added to the 3, but it's not clear to me. Gain on left. The node value. What is this current max path? This is what I don't understand. So if the current node's value is negative, then I would say the current max, okay, this is what they're, it's just a variable naming thing. So this max path is going to potentially beat that, okay. Well, on the one hand, it doesn't seem like a hard problem to me. This has got to be like the easiest hard, huh? But on the other hand, my answer doesn't work, so I'm missing something. All the same with difficulty, ignore the Leetcode rating. That's that guy's opinion. So is this going to work? Okay. Yeah, what's wrong with this code, man? Check left. He says gain on left. Check right. Gain on right. Just joined. I see what you're doing, but what are you doing? Thanks for the follow, Maroof. I'm trying to solve binary tree maximum sum path. The good thing is, like, my approach is identical to what bro over here said I should be doing. So that feels kind of good, I guess. The bad news is it didn't work for me. So I tried the left and the right, which I have commented. So I'm puzzled about needing to force the node value here. Yeah, okay, so this is a way to skip over the 0 problem. That's what it looks like. Since you're always adding it to, it almost like works coincidentally. Since you're always adding it to the node value, you will never float up your child's 0. Does that make sense? So this is it's like a bottlenecking approach. That works for me. And then, yeah, you just have this global float. Okay, so that's the key difference. So here, I was like flowing up the tree from the leaves to the root, right? But the reason that that's tricky is because you could have, like in the example, the 1527, which doesn't flow up through the root. So what I did to solve that is I said, oh, well, let's just say that this 10 node, the negative 10 node, let's just say that the negative 10 node's best option is either of its children with or without himself. And that got me around the problem of being able to ultimately recursively return this lower fragment. A different way around that zero floating problem is you just have a different data structure that's outside of the tree itself, and this individual is using the non-local max path to that end. Does that make sense? I have an Atlassian interview Friday. I'm Leetcoding right now as well. Good luck. Are you job searching or Leetcode for fun? This is just for fun. What is LSR? LSR means left, self, right. So that would be 1527 would be the LSR with respect to 20. All right, cool. So given that I understand the difference, can I fix my implementation? I can, but it basically just looks like I'm copying this dude. And what about the candidates option? Well, it's going to have the same problem where I'm floating up the tree. Although I still couldn't tell you what's wrong with saying 4 here, because it looks to me like 4 is a sub tree with a higher value. So I don't know. Something about the way that this argument is getting passed is like, it doesn't reflect the tree structure. Okay, so let's go ahead and rewrite it just so we can get the win. So here we are. We're going to go back to passing the 0 here. We're going to get rid of this candidates. All right, so we're doing this approach, but we are going to have a global max. We can float it to negative infinity. Do you put the minus inside of there or outside of there? So what do I return? I want to return the cur max. And then I want to say the global max is the max of that or the cur max. Okay. All right. And so what's the cur max? I need to bottleneck through my tree and always bottleneck on self. I don't have the luxury of floating up the children without self. Okay. So I can say left self right or left self or self right, but I can't just do what I was doing previously, which was like left self right, self right, or left or right. I can also do the root val, I think. Ignore both the children, yeah. But I can't do the left or the right there. Thanks for the rose. Katarina, thank you for the follow. Okay, so here's cur max. So cur max is going to be the max of the LSR, LS, SR, or root.val. Those would be the options then. Cannot access it where it is associated, not associated with a value. Okay. We'll put it on the solution class. I guess it's losing a reference somehow. This is like the wrong syntax, right? I need a constructor. Cute vibes. Thanks for the rose. I'm sleepy, y'all. How about you? Oh, DEF. Take 0 positional arguments, but 1 was given. Yo, how are we passing globals these days? How are we passing globals these days? What did I just read on this other guy's solution? He's going to put it right here. Non-local. He's doing it as a non-local. I'll do that, but I want to go and try this one more time. And see if it's just because of where my hyphen was, like my minus sign. Cannot access local. No binding for non-local. Wow, okay. Weird. So it wants it like floating in the solution class. I'm not used to this syntax. This feels like a TypeScript thing to do. It's still giving me no binding. Oh, it's a nested function. It's a nested... Is it a nested function with like messed up indentation? Okay, it's a nested function. Solve the problem, your attribute information. It should be minus INF instead. I don't think so. I think the syntax is fine. I think it's the fact that it's a nested function. This is actually the right syntax for a non-local here. So let's indent all this stuff. Invalid syntax, non-local global max. Yeah, non-local should be on the nested. Implementation. Sovereignty, thanks for the follow. All right, we passed the compiler, but it's mad at us. How did I get 41? Yeah, that's weird. Literally, how can you add these numbers to get 41? What? Oh, if you just add all the numbers, is that... that'd be 41, right? If you just add all the numbers, it becomes 41. Yeah. How is that happening? I feel like I'm not just adding all the numbers, am I? Self max path sum. Oh, okay, let's do this. I don't like the nested function thing. I feel like, who says that? Leetcode says to do that. I'm not here for it. Boom, roasted. The null should be 0. Where's the null? Cinema Pixie, thanks for the follow. Bathsheba, welcome in. Thanks for the likes. So why am I recursing too far? So I go down the left, okay? I get max gain on the root. Did I just not de-dent enough? That's not the problem. Okay, so I got this global max. Then I want to get max gain. Oh, okay, I'm shadowing root. That's the problem. I'm shadowing root. Let me call this thing child. Okay, so then it's child left, child right. Yeah, that was not good. This is great. Knocking the rust off, eh? So none type object has no attribute left. Right. How accurate, how literal is this other dude's code? So like, he's not guarding left either. And his root is not even optional. I wonder if they updated the problem to make it optional. I just do this. Whoa, how did I get 4? Well, we got 73 out of 96 test cases passed. That's cool. What's the issue though? Working in light mode is insane. Yeah, let's change it up. Oh, you actually have to set Chrome to be in dark mode? It's gonna end the stream if I do that. I'm gonna cancel that. Sorry. I think it'll cut the stream because I have to relaunch Chrome to apply the flag. This is kind of cool though. Night eye extension. So why am I getting 55? It's just the sum of all the numbers. Close your eyes, instant dark mode, based. So 55 is the sum of all the numbers, but it expected 48. Why did it expect 48? Oh, you can't like traverse up both. You can't make like a Y traversal. Yo, I'm just trying to copy this guy though. Read the last image on going down the recursion stack. Got it. I think this is the bit that I'm missing. Max gain on left or gain on right. Because you can't make the Y shape. You can't do both. Yep. Okay. So we don't return cur. We return left plus right. I guess that's the interesting little wrinkle. The Y shape problem is the interesting. Yeah, I didn't think of that. I guess that's the thing that makes this hard, allegedly. It's an additional wrinkle that's not in the base path sum problem. Node is not defined. I meant child. Sorry, variable naming. Cool. Wow, I still failed. Wow, that feels bad. Return. Let's look at this person. So this person put it outside. I like that. I prefer this structure. Oh, I still didn't do it. I still didn't do it. Lightning judger, that's interesting. Int object is not iterable. What? Good. All right. Yeah, reading it phrased the other way helped me like understand what I was doing wrong. Cool. Well, on the one hand, that roasted me. On the other hand, I don't actually think that that's a hard Leetcode problem, so that's fun. Hey, chat, thanks for being here. And yeah, if you thought this was interesting, follow the channel. I will commit to you that I'll knock some of the rust off, and this won't be so embarrassing next time around. Thanks for joining me. This was 124 binary.